All right, welcome, guys. So today we are going to continue our discussion on containers. We're going to be looking at Amazon's Elastic Container Service, and we're going to look at deploying our Docker containers. So when we kind of started this series, we started out talking about Docker, how to build containers and deploy containers in a development environment. Then we looked at building a Selenium grid using Docker so we could actually create some test environments to test multiple browsers within our development environment. And then the last one we talked about, we looked at using Kubernetes. So today we're going to finally take our containers that we've been looking at and using locally, and we're going to actually publish them and push them out to the cloud, put them out actually in the web where we can actually use them from other networks across the web. So let's get started. So today we're going to basically go over kind of what is the ECS. So we're going to talk about what it is. We're going to look at why we should be using it, how it works, when to use it, and then we're going to walk through a full demo using the ECS in action. So we're going to essentially go through the normal process. We're going to go through basically the hello world, getting it set up, and then we're going to go through and take our Spring Docker container example that we built using Spring Boot and Spring STS, and we're going to push that container up into Amazon's ECS environment, and then we're going to publish it there, and then we're going to test it online. So let's start. What is Amazon's ECS? Well, ECS stands for Amazon Elastic Container Service. So it's basically Amazon's container service that they provide for us to scale high performance containers using Docker and some of the other container packaging tools out there, but Docker's pretty much the most widely used, which we can easily scale containerized applications on the AWS platform. Now, ECS eliminates the need for you to install and operate your own container orchestra software, manage scaled clusters of virtual machines, or scale containers of those virtual machines. So if you went through the last few lessons with us, you would see that there is a bit of maintenance and a bit of setup to actually do these in a local environment. If you actually try to deploy and manage your own commercial or your own production environments, the maintenance and the scale gets to be a little more time consuming and a little more tedious. So Amazon eliminates that. They give us this easy to use tool called ECS. It also has simple API calls. So like Docker, you can use it from the command line. You can easily stop and enable Docker applications from the command line. And you can do a lot of things also through the GUI. But why use Amazon ECS? Well, we can use it to run containers without servers. So the Amazon EC2 features what's called AWS Fargate. So you can deploy and manage containers without having to provision or manage servers. With the Fargate, you no longer have to select the Amazon EC2 instance types, provisions, and scale clusters of virtual machines to run your containers or schedule containers to run on clusters and maintain their availability. So the Fargate enables you to focus on building and running applications, not the underlying infrastructure. So that's one of the huge benefits to using EC2. The next one is containerize everything. And this has kind of been an ongoing theme as we've been talking about containers. So Amazon ECS lets you easily build all types of containerized applications, from long-running applications and microservices to batch jobs and machine learning applications. You can migrate legacy Linux or Windows applications from on-premise to the cloud and run them as containerized applications using the Amazon's EC2. Security, secure. You definitely want your applications to be secure when you put them out in the cloud. Well, Amazon EC2 launches your containers in your own Amazon's VPC, allowing you to use your virtual private cloud security groups and networks, ACLs. No compute resources are shared with other customers. So you have your own private cluster. You can also assign granular access permissions to each of your containers using IMA to restrict access to each service and what resources a container can access. The high level of isolations helps you use Amazon's ECS to build highly secure and reliable applications. And of course, the big thing with containers is we want to be able to scale. So as we deploy these containers, we want to create clusters and have load balancers. Well, again, Amazon is perfect for that. So the Amazon ECS is built on technology developed from many years of experience running high scalable services. You can launch 10 or tens of thousands of Docker containers in seconds using Amazon's ECS with no additional complexity. The only gotcha you're going to see today is because we're using the free tier, we only have the ability to scale up one container. However, we can scale more. We charge for it, and I'm not going to do that because I want to not break the bank. So lastly, we've got designed for use with other AWS services. So since we're using Amazon's ECS, it plays nice with all the other tools that the Amazon suite has to offer. So Amazon ECS is integrated with the following AWS services. So providing you a complex solution for running a wide range of containerized applications or services. So it works with Elastic Load Balancing, Amazon VPC, AWS IMA, Amazon ECR, which we'll see a little bit later, AWS Batch, Amazon CloudWatch, AWS CloudFormation, AWS CodeStar, and AWS CloudTrail. So how does Amazon ECS work? Well, we start with building a container. We have to have container images in order to deploy things to the cloud with microservices and containers. So we can create, build, and push container images to a registry. So you can use your local Docker instance and build your own containers, or you can download the Amazon EC2 images to your local machine, customize them the way you want, test them locally, and then push them up to Amazon. So then you can define your application. So we're going to select container images and resources needed for your application, similar to what we did locally, and launch containers. So instead of launching them locally, either through Kubernetes or through Docker, we're going to launch our containers using the ECS launch containers environment, so for your applications. And then we can manage all these containers using the ECS little dashboard that we have, and ECS scales your application and manages your containers for availability. It's real easy to use, similar to what we saw with Kubernetes and with the Docker kinematics. So when do we want to use Amazon ECS? Well, if we're dealing with microservices, Amazon's ECS helps you run microservice applications with native integration to AWS services and enables continuous integration and continuous deployment pipelines. Batch processing. Amazon ECS lets you run batch workloads with managed or customer schedulers on Amazon's EC2 on-demand instance, reserve instances, or spot instances. Application migration to the cloud. Again, if we want to get rid of all those legacy applications, you can do that. They can be containerized and easily migrated to the Amazon EC2 without requiring code changes. Machine learning. One of the hot topics in the industry right now, that Amazon's EC2 makes it easy to containerize machine language models for both training and inference. You can create ML models made up of loosely coupled distributed services that can be placed on any number of platforms or closed to the data that the applications are analyzing. So you can open it up to the world, or you can kind of keep it in a closed, self-contained environment. So let's talk about our demo today. So the demo, we're going to deploy our Docker containers to EC2. So we're going to start by setting up an AWS EC2, or not EC2, but ECS instance. We're going to create a task definition. We're going to configure our services. We're then going to configure our cluster that our services are going to run so that we can actually have a load balancer and spin up more tasks. We're going to launch and view our resource. We're going to open the sample application, make sure everything's working correctly, and then we're going to clean up our resources. Finally, we're going to take that example Spring Boot Docker example, and we're going to deploy it to our Docker instance. To our, not Docker, but to our ECS instance. All right, so we need a few things first. So let's drop out here to our demo. Let's see, where's that? All right, so the first thing we want to do is you need a Amazon account. So AWS console. So once you create your account, so you can start here, create a free account. All you need is an email address and a credit card. If you already have used up your free tier, go create a dummy or basically a throwaway Gmail account, which is what I did for today's example. And you can reuse the same credit card you've used for any Amazon console accounts. As long as you have a new email address, the credit card essentially resets and you get another year free. So first you sign up for your AWS account. Once you have your account, you then log in to the console and you'll get the basic screen here. Pick a region that kind of meets with your demand. So if you're in the central, kind of use Ohio. If you're on the Pacific, use California. If you're on the East Coast, use North Virginia, etc. You don't necessarily want to have London and have your test accounts bouncing from here to London. They'll get pricey. Here's our account information here. And if we click services, where we want to go is we want to go under compute. And here we have the Elastic Container Services. We can click and access it from here. Or if we go back to the main console, you could just type ESC or Elastic Container Service, and that will also take you there. Now, Amazon gives you wonderful tutorials and quick starts, so we're going to follow their directions here. And by using this little quick start here, this actually jumps you in to using that, what was it called? The Fargate. So their little tutorials actually use the Fargate to help you quickly set up the demo. Yeah, here it is, Fargate. So first we need to set up our container and tasks. So since we're using their examples, we can just quickly click one of these here. They have a Tomcat server, they have a sample little Apache server, and then they have an NGINX. We're going to take the sample app. So this is real quick. Come down here, task definitions, first run task definition, what network mode, it'll be AWS VPC, create a new one. We're going to use Fargate. We're only going to use half a gig of memory, and we're going to use a very small CPU. Now, if you don't like that, you can come in here and click edit, and then you can upsize this however you wish. Just bear in mind, if you get a little too cocky or a little too memory intensive, you're going to start getting charged. So we'll keep it with the basics. You can change your role or create a new security role. And you can change the name if you wish. So we'll just leave that as is. And next. All right, next we have to pick our service. So we have our service name by default, number of desired tasks, automatically create a new one. And we're going to want to enable the application load balancer because we want to enable this so that we can scale up our containers and actually spin up anywhere between 1 to tens of thousands based on our load. And then since this is just a sample Apache application, we'll leave port 80 open and HTTP. Now, if I want to change anything else, I can come in here. I can increase our tasks here. Be careful though. Under the free tier, you are only allowed 1. If you go higher than 1, you will be charged. You can also change your security group block. You can change the IP addresses, your application load block, load balancer here. You can change the listening port. You can change some of the advanced settings here. We'll leave all this to the default. Click next. We can change our cluster name or just leave it as default for right now. We'll just keep it default. And then review. So here we have our task definition, network mode, our task role, our container name, our Apache image, memory is only 512, port 80, HTTP. And then our cluster name and our services. So we hit create. And it says it can take up to 10 minutes, but I found this only takes 2 to 3 minutes. As it's sitting here, it's going to start building the ECS resource creation. So the first thing it quickly built was the cluster, then it builds the task definition. It also generates the log group. Mine already exists since I ran this earlier, just to make sure I had everything configured correctly. It'll take a second here and you'll start seeing all these others. So there's the VPC, believe. There's security group, the cloud stack, or the load balancer should be next. Here we go. Oh, subnets, okay. It's kind of interesting too, because if you actually watch the order as these get generated, if you go through the launching your internet business and you watch how we built the Amazon EC2 instances, it's very similar to the steps we went through to build our EC2 instance, and then defining the elastic IP addresses, and then set up the S3 DNS information. It's almost there. So we're waiting on the load balancer and the cloud stack. And as these things load, you can also click on the individual tabs and go out and look at the information that it's generating. So here's our subnet. By the way, VPC is virtual private cloud. Still waiting on that guy. All right, while we wait for him, swing over here. So on my command line, in order for us to actually push our Docker images to the cloud, we have to install an additional command line tool. We have to install the Amazon CLI command line interface tools. And to get to those, waiting on that guy, still putting. So you go to aws.amazon.com/CLI, and this will walk you through finding the correct installation that you need for Windows, Mac, Linux, Amazon Linux, and some additional release notes, some shell information, and a quick study on how to use the commands. So for Mac, I'm on terminal. So the first thing we need to do is make sure that you have Python 2 installed. And then once you do, you want to go to your downloads folder. And you want to download the Amazon CLI package. So since I'm on Mac, it's CURL https s3 amazonaws.com/aws-cli/aws CLI-bundle. And I'm going to download it to AWS bundle. Doesn't take that long. Then you unzip your package. And then you run the install executable. I'm not going to run this because I've already ran this. And, what the hell? So it takes a second to run. Back over here, let's check on our progress. Oh, look, everything's done. So once everything has completely been built and created, we can then go to View Services, which if we actually were to go back to Services and go to your Elastic Container Service, you see the same thing. So you have your cluster, which is default. And if we go into default, we now see the same environment that we saw from before. So our cluster is running, our service is running. So here it is, health check 0. All looks good. Go to our tasks, click our task. And task is important because if you scroll down, let's see, we have network, sample, there's more details. Go back. Look at the task definition. It's running. Oops, wrong one. Cluster. ECS instance. Matrix, it's not quite there yet. There it is. So under network, we have our public IP. So now if we go up to our command line and type it in, Amazon ECS sample has been deployed. So we have successfully deployed the Hello World example. So once it's deployed and you're all done and want to clean it up, you can hit stop to kill your task. Go back over to your cluster, delete your cluster. That will tear down all your resources. And while that's going on, we'll go back over to our command line. Okay, everything's been installed. Oops. And there's our AWS, so that guy's installed. So now we need to create an Amazon Elastic Container Registry to upload our images to it. And this guy is still running, so we'll give him just a second. Close those. Still deleting the resources. All right, so next we need a repository. So like Docker, you can create your repositories online and upload your images online. You can make your repositories public, or you can keep them private. So here, we typically want to keep our repositories private unless we're sharing them with other developers. So the first thing we do is we want to create a repository. So we're just going to call this one Spring Boot for a quick example. So the permissions, it's you have permission by default, but you have to grant other people access. Next step, great, repository is built. That was all you had to do. So now if you actually come out to the ECS, go to repositories, we have our Spring Boot repository. You can define your permissions, you can do a dry run of the lifecycle, and there's your lifecycle policies. So right now we have no images. So again, oh good, he just finished. And last thing we want to do is we want to just become active. Oh, there he goes. Okay. He'll go inactive in a minute. It's just still cleaning up. All right, so we got the repository. So now we go over here. So the first thing we want to do is we need to configure our command line interface for our repository. So since this is a demo account, I'm going to show you how to get your access keys and create some security credentials. You can take note to what I put in here today, but come the end of this class, this will be destroyed and they won't be valid anymore. So if we go to our account up here, demo.aws.developer, you go down to my security credentials and just continue to security credentials. Then you click on this access keys, access key ID and secret access key, and then you click create new access key. Well, I've already created one here, so when it created it, it gave me the access key and the security key, which I will use to register my command line tool. So I'll jump over here. Shift this over a little bit so it's not off the screen. All right, so the first thing we need to do is we need to register the credential. So on your command line, you type in AWS configure, and it's going to prompt you for your access key ID. So you just copy and paste it in, like so. And then you type in your security key, like so. And then you put in your default region name. The default region name is going to match what you have set up over here for global. So if you go back over your services, go back to your Elastic container. So mine's Ohio. And if you look up here, it tells you your region is actually US-East-2. So that's what we put in here. Default output format, you can leave that none. And now our command line tool is registered. Next, we need to log in to our AWS EC2 login so that we can actually get the Docker login information to connect to our EC2 repository or ECR repository. So if you typed in AWS space ECR space get login space dash dash no dash include dash email space dash dash region space US dash east 2, it then generates this big honking piece of text, which you just copy and paste, and you're now logged in. All right, so next, we need to build our Docker image. So we need to go to our development environment. So go to cd space gs.docker. So I'm using the generated source Spring Boot Docker Complete image. We talked about this in the previous Docker example. So if you want to see how to generate this, go back to one of the previous container tutorials. So we already have our Docker image, but if we look in here, here's our source code. It's just a Spring Maven or a Spring Boot Maven repository. We have our Docker file here that contains the information for building our container. So we're going to use the OpenJDK 8 library. We're going to set a shared volume of temp, and we're going to pass in the arguments jar file, and it's going to be app.jar, and the entry point will be Java. We set the security to random jar and deploy the jar. All right, so then to build the Docker file, you run the command maven or /mvnw space install space Docker file and build. So I've already done that, so I don't want to do it again. Once it's built, make sure Docker is running. So I'm on my Mac and I'm actually using the Docker little GUI tool that gets installed. So once Docker is running, you can then make sure it's running by typing Docker. And if you get the commands, it's running. If it's not running, it will fail. So to see our images, we type Docker image ls. This gives you a list of all your images. So the one we're looking for is this guy here, springio/gs-spring-boot Docker. And our tag is latest. So next we want to upload. So if we click our Spring Boot repository here, and if we click the button View Push Commands, this lays out what you need to type in order to upload your file. So first you have to log in, then you need to build your Docker file, and then you need to tag it before you upload it. So the first thing we're going to do now is this guy here, although I've named it slightly differently. So I have, so here we're going to do Docker tag because my local image is springio/gs.spring. I have to define that. I then have to specify the tag, and then I give the ID for our AWS ECR container, which is Spring Boot latest. So it's now build my tag locally, and now I want to push this image up to our Amazon repository, our ECR. So you use Docker push, use our ID for our repository, and the repository built Spring Boot and latest. And pushing it up. Almost done. And ta-da, it's there. So to verify, we go over to our ECR, and there's our Spring Boot. There's our repository URI. Click Spring Boot. There's our latest that we just pushed up, and it was pushed right now. And permissions are still our own. We have no additional permissions. We're going to leave this as the default and leave the lifecycle as the default. So now let's make sure our task, why is this guy not going away? Oh, there we are. Deregister. Now he's inactive. Okay. So now we go back up to our cluster. So we'll follow getting started again. But instead of using one of the predefined containers, we're going to use our own. So we click Configure. And we're going to do Custom Spring Boot. And we need our image repository. So we click back over here. And we need the repository. And we want the latest. So it's basically registry URL, namespace, image, and tag. So there's the URI and the image and the tag, soft limit, memory limit, 128. For this one, we're going to map the ports to 8080. Leave all the health checks alone. We don't really need to change any of that. We can update CPU units, but we'll leave everything the default. So update. So we're going to use the basic test definition. So we're, again, going to use AWS, 512 memory, and a very simple CPU. We're going to use our application load balancer, which opens up the port 8080. Next. And just default cluster. Actually, we'll say default Spring cluster. Next. Review. Test definition. All that looks good. There's our 8080, and we're pulling from our image. Then create. And now it's going to go out and build our EC2 instance, our ECS instance. And that'll take just a minute. So let me show you what that actually looks like before it deploys. So if we go to STS, so here's our Docker file. We have the GS Spring Boot Docker complete. We have our hello application. That is essentially a little REST application, but from the command line, or I'm sorry, from the root of our URL, if we put in root, it'll just print out hello Docker world. So just a little simple test application to test our Docker build. Almost there. Some other things to look at while that's running. So you've got your cluster. So your default cluster information here tells you how many services you have running, how many tasks are running, how many are pending, how many EC2 instances is it spinning up to go with your cluster. Again, services, pending tasks. You can change your view. You can upload multiple tasks. If you need to look at your task, you can click in. Here's your builder. You can create a service, update, run task, deregister, removes it. Kind of like when we do delete container from Docker. There's our network mode, our memory. View it in JSON. This is interesting too, because if you actually define this locally and you want to test everything the same as you were going to test in your cloud, you can export this JSON and import it into your local configuration so you can test everything the same locally. Almost done. Check out your repository. You can view all. You can see all the different tags you have. You can also increase your limit increase, so number of images to 1,000 per repository. If you need more, you can increase that. Clusters, we now got one service running. There we go, finished. So view service. So here's our cluster, our task definition, our details, the network access, auto assign public IP is enabled. So we then have to go to our task. You have to be careful. If you click the actual task definition, that will take you to our task screen, which we don't want. You actually want to click on the task, but you want to click on the actual task itself. This will give you the network information, your logs, and then the public IP address. So if we copy this guy in, paste, oh, not going to find it at 80. We defined it as 8080. And there's our Hello Docker world. And when we're all done, we come back in. And we stop this guy. Delete our cluster. And deregister our task. And if you're all done and you don't need your repository anymore, you can come in here and you can delete your repository. And now everything's back to where it was when I started. Cluster will take a minute to fully clean up all the resources, but while it's doing that, we can go back to our slides. All right, so we talked about what ECS is. So it's Amazon's way of Amazon service for deploying our containers to the cloud. Why should we use EC2? Well, we should use EC2 on ECS to run our containers, to containerize everything for security, performance, and scalability, and again for the design and the use for other AWS services. We walked through how the ECS works. When do you want to use the ECS or ECS for the microservices, containers, and such. And we went through a full walkthrough of building an ECS instance and deploying some containers. Quote for the week: the first rule of any technology used in a business is that automation applied to an efficient operation will magnify the efficiency. The second is that automation applied to an inefficient operation will magnify the inefficiency. Bill Gates. Thanks for your time. We appreciate your time. We'd love to discuss any questions you have or further for future topics. You can send us questions, comments, and suggestions to any of the following methods: info@developerner.com, developerner.com/contact us, @developerner, and follow us on Facebook at facebook.com/developerner. Does anyone have any questions?
Hey there, Michael. I was just listening and watching that as well, but I may have missed it where you're using ECS and did I hear you say you put a load balancer there, or you can put a load balancer there?
I did. Yeah.
Oh,
Let me. It may not still be there, but when you go through the process of building the cluster,
so
we'll just grab the sample app here. Next, right here when you define your service is where you set up your load balancer.
I'm with you. Okay, that's cool. I was just wondering, could you think of any tests to see if we could overload it and then see the load balancer kick in? What type of tools does AWS provide to watch that traffic and then know when that load balancer is kicked in? You know what I mean?
That's a future discussion.
Gotcha. Okay, cool.
Yeah, I've actually got one or two more with the Amazon tools to expand on this, but I wanted to keep this one short and simple because you can kind of get lost with all the bells and whistles you can do.
Absolutely. Well, that's good, though. It's a good presentation.
In a way, if you look at this, if you think back to the Kubernetes, unless you actually expose your service, you can't actually hit your service on your local machines. Same thing kind of applies here. Unless you actually create a load balancer, if you notice I hit none, I lose my port. So you can't actually hit it. So they've essentially set out to force you into using a load balancer, which is really the right thing to do when you're using containers.
Mm-hmm. Okay. Another kind of question, and this may be as simple as just hitting the load balancer on. I guess I'm coming from a very personal standpoint in hosting servers and things like that. So from a company or a large-scale network standpoint, I'm a little novice. So if I were to host my DNS and point my DNS toward that load balancer, I guess how would that work? Can it help me not be so novice in that?
Actually, you're going through the Launching Your Internet Business course right now, correct?
Yes, sir.
I believe we discussed that a little bit in that course, because you can set up a Route 53, which is kind of your DNS.
Yep.
I don't have that set up on this particular example, but once you set up that, then you can also set up, where is it? Let's go EC2. So you can then set up an Elastic IP, and then you can set up your load balancers here. So Amazon really has it all set up for you to really build an enterprise solution for a small business in a matter of minutes. The trick comes in how you set up your security roles, what ports you open up, and then how you lock down the actual servers themselves. So like if you're doing like a Linux box, you want to make sure you log in, and then as soon as you log in to the EC2 user, you want to create a new admin user and then essentially lock down that EC2 user so that it can't be hacked into.
Yeah.
And we cover a lot of that in the Launching an Internet Business course. So as you go through that, you'll see some of these things.
Sounds good. I have gone through that part with the separate user as opposed to the EC2 user. So, yeah.
And then the one thing, though, we don't cover in the course, we don't talk about, is the load balancer side of it. So that's the rest of it is all there, but the load balancing we actually did not get into in that one. So if that's something that you're looking for, then you'll have to play around with it a little bit.
No worries. Good deal.
Well,
Sounds
yeah,
like
play
fun.
around with it a little bit or wait for the next segment of this because I will be getting into some of the more advanced configurations you can do with the containers with Amazon. This one was focused on Docker. The next one I'm going to focus on will be Kubernetes with AWS, and I can try to tie in with that one. I can add some more discussion on the load balancer and maybe some of the monitoring tools.
Very cool. Yeah.